Hello, hi everyone. Welcome to the Student Brand. So this is your Svas here. Today we are going to discuss about magnetic effects of electric current. Magnetic effects of electric current. Okay, so let's start the topic. Magnetic effects of electric current. Okay. So here till now, so 8 sessions were completed. So I took 8 sessions. Okay, so like 7 sessions completed. This 8 session. So okay. Now in this session we'll completely discuss about magnetic effects of electric current. Magnetic effects of electric current. Okay, so mhm, mhm. Magnetic effects of magnetic effects of electric current. Electric current. So here you can observe the name itself. Now the name itself it is there. So when the current is passing through the conductor, when the current is passing through the conductor, so it behaves as it behaves as a magnet. When the current is passing through the conductor, it behaves or it produces or it acts as a magnet. Okay. So now we'll discuss about magnetic properties. Magnetic properties. So natural magnet is magnetite. Natural magnet is magnetite, which occurs from earth crust. Magnetite is a natural magnet or lodestone. So what is meaning of lodestone? So it's like a leading stone. So before finding all these things, compass, everything, so people are moving on the ocean, they couldn't able to find a particular direction. That's why they are using this stone to identify the direction in particular direction. If you suspend that magnet, so always it shows north and south direction. So that's why so they are using that one to move on the oceans, okay, in a particular direction, whichever direction they want to go. Okay, that's why it is called leading stone. So magnetite or lodestone, okay, so these are natural magnet which occurs from earth crust, understood or not? Oh, yes. And next point is, so if you suspend the magnet, always it shows north and south direction. Suppose coming to artificial magnet. So man-made magnets are artificial magnet. So naturally occurring magnets are natural magnet. Coming to the artificial magnets, okay, which are occurring, so which are made by the humans, made by the humans according to our industrial requirements. Okay, so here we are using so different types of magnets. So u-shaped magnet, horseshoe magnet, dumbbell shaped magnet, cylindrical magnet, so like different types of magnets are using. Especially coming to the bar magnet, okay. So here if you are taking the bar magnet, so I'm considering this a bar magnet. So here, understood? So north pole and south pole. This is north pole and south pole. Okay, magnet has two poles. North pole and south pole. If you drop the magnet into the sand, it always attracted at the ends. Those are called poles. So magnet has two poles. Poles has equal strength. Okay. So around the magnet, magnetic field will be there. So first one is around the magnetic field will be there. So magnetic field, and coming to the next one is, so properties of the magnetic field lines. Properties of properties of the magnetic field lines. Properties of the magnetic field lines. Magnetic field lines. Properties of the magnetic field lines. So the region around the magnet. So the region around the magnet in which magnetic force exert. The region around the magnet in which magnetic force exert. The space around the magnet in which magnetic force exert. The region around the magnet, the space around the magnet in which magnetic force exert. Okay, so magnetic force exert is called magnetic field. Okay, so until certain region only the magnet will attract the magnetic materials. Until certain region. So if you are taking this the magnet, until certain region only the magnet will attract the magnetic materials. Understood? So this if I take a magnet, so around this one, around certain distance, okay, certain distance only, the magnet will influence the another magnetic materials. So magnet will influence the another magnetic materials. Understood or not? So until certain region only, until certain distance only, the magnet will attract the magnetic materials. The magnet will attract the magnetic materials. Understood? So those are, that is called magnetic field. That is called magnetic field. So the magnetic field will be in the form of field lines. Magnetic field will be in the form of field lines. Around the bar magnet, magnetic field will be there. We know that. But how it will be in the form of magnetic field lines? In the form of magnetic field lines around the bar magnet. Understood or not? Around the bar magnet, the magnetic field will be in the form of field lines. In the form of field lines. Okay, that's good. Correct. Next one. So what are the properties of the magnetic field lines? What are the properties of the magnetic field lines? Point number one. So these field lines emerge out from north and merge at south. These field lines emerge out from north and merge at south. Point number one. And coming to the next point is, coming to the next. So these are closed loops. Point number one. Emerge out from north, merge at south. These are closed loops. And inside of the bar magnet, the magnetic field is south to north. Outside of the bar magnet is the magnetic field is north to south. These are closed loops. And the next point is, these field lines never intersect. These field lines never intersect. So if it is intersect, so what happens? If it is intersect, so what happens? So normally compass is there. Compass is a small magnetic needle present inside of it. A small magnetic needle is present inside of it, that is called compass. It always shows north and south direction. It always shows north and south direction. Is it clear? North and south direction. So if you want to identify the direction of the magnetic field at particular point, if you want to identify the direction of the magnetic field at particular point, you have to draw the tangent. Okay, so if you draw the tangent, so I am drawing the tangent. So normally magnetic field lines are, okay, so here you can observe, these are the magnetic field lines. So these are closed loops. So I am taking here one, and next one here also two, and next one here three, and next one here four. So these are the magnetic field lines. Okay, so these field lines are closed loops, and here you can take 3, and here middle one, and here also I am considering like this. So magnetic field from north to south, north to south, north to south, north to south, away from the magnetic field, like this, like this, like this, and towards the here. So at the south pole the magnetic field will be inward. At the north pole the magnetic field will be outward. Understood or not? So we know that. Okay. So now we can observe. So magnetic field around it is north to south, inside south to north. These field lines never intersect. If you want to identify the magnetic field at particular point, you have to draw the tangent. So tangent at this point, and tangent at this point, and tangent at this point. I have to draw the tangent here. So I have to draw the tangent here. So if you draw the tangent to the magnetic field line, at that particular point, we can identify the direction of the magnetic field, direction of the magnetic field at particular point, okay. So by drawing the tangent we can understand the, so these are properties of magnetic field lines. And if it is intersects, so if field lines intersect, so what happens normally? So as I mentioned, you have to draw the tangent like this. Okay, so at this point the direction will be like this, at this point direction will be there. Okay, so as I mentioned, compass is used to identify the direction of the magnetic field. Okay, anyway it always shows north and south direction. So at that particular direction, if you draw along the direction, compass will show the direction. So if two field lines intersect, so at a time compass should show two directions where it is not possible. So compass cannot show two directions at a time, right? Compass cannot show two directions at a time. Only one direction at a time it will show. One time only one direction, that is north and south. Okay, along the free north pole direction, the compass will show the direction. If two lines intersect, so two directions, compass should show two directions at a time. It's not possible, right? So that's why two magnetic field lines never intersect. These are closed loops. Okay, intersect, it won't intersect. So those are the properties of the magnetic field lines. Properties of the magnetic field lines. I hope it is very clear. So next one we'll discuss about current carrying straight conductor. Current carrying straight copper, long straight copper conductor. Okay, so this is about magnet. We discussed till now about magnet. Okay, so here you can see. So long straight copper conductor I am considering like this. Long straight copper conductor. Okay, here. Like this. So now you can see so ammeter. So here rheostat, this is a rheostat, and here I am taking the battery. This is the battery. Okay, positive terminal, negative terminal, switch. Current is passing. So this is the long straight conductor, long straight copper conductor, long straight copper conductor. So current is passing like this. Current is passing like this. Understood or not? So here you can observe. Okay, current is passing like this. So north and south. This is north, south, east and west. North, south, east and west. If you place the compass, so it always shows north and south direction. It is like this. Okay. So if the current is passing through the conductor, straight conductor, if the current is passing through the straight conductor, understood or not? So you can observe here. So here you have to place the compass. Here you have to place the compass. Okay, current is passing from north to south. Understood or not? Current is passing from north to south. If the current is passing from north to south, so we know that magnetic field will be created. Magnet will be produced around the conductor. We know that already, right? So when current is passing through the conductor, magnetic field will be produced. How the magnetic field will be around the conductor? In the form of concentric circles. Okay, these are concentric circles. So like a closed loops. So these are closed loops like this, like this, like this, like this. Okay. So current is passing from north to south. So the deflection in the compass will be shown towards east. The deflection will be shown towards east. If the current is passing from south to north, the deflection will be towards west. Sir, I know one condition, that is, if the current is passing through the conductor, magnetic field will be produced, right? Sir, we know that one thing. If the current is passing through the conductor, okay, so magnetic field will be created. So magnet will be produced around the conductor. Yes or no? Magnet will be produced around the conductor. Clear? But how can we identify the direction of the magnetic field? Here is the question. How can we identify how can we identify and in which direction the magnetic field will be there? By using right hand thumb rule. Okay, so if the current is moving upward direction, so along the thumb, so this is the right hand thumb, so along the thumb, so if the current is passing, you have to place the thumb along the current carrying conductor. Okay, thumb you have to place along the current carrying conductor, and curly fingers, folding fingers, wrapping fingers, okay, curly fingers, folding fingers, wrapping fingers shows the magnetic field direction. Understood or not? So this is the thumb. Along the thumb, the current is, so around the current carrying conductor, you have to place the thumb. Okay, so I am placing like this. So curly fingers, folding fingers, wrapping fingers represent the magnetic field direction. Understood or not? If the current is passing upward direction, magnetic field will be produced around the conductor like this. Yes or no? So yes. Okay. So if the current is passing upward, the magnetic field will. If the current is passing downward, the magnetic field will. If the current is passing along this direction, the magnetic field. If the current is passing along this direction, the magnetic field will be there. Right? So if the current is passing towards me, so if you place the thumb along the current carrying direction, then so the magnetic field direction is clockwise. The magnetic field direction is clockwise. If the current is passing towards you, so along the current carrying conductor, you have to place along the current carrying conductor direction, you have to place the thumb. And curly fingers, folding fingers, wrapping fingers shows the direction of the magnetic field. That is anti-clockwise direction. Understood or not? I hope it is very clear. So this is about current carrying conductor placed in the external magnetic field. Okay, so here you can observe. Understood? So this is enough. So around if the current is passing through the conductor, magnetic field will be produced around it. Understood or not? Yes. So by using right hand thumb rule, we can identify the direction of the magnetic field. Understood or not? So we can identify the direction of the magnetic field. Okay, done. So that is correct. Right. So now you can observe. So near to the conductor, the magnetic field lines are concentric circles. Near to the conductor, around the current carrying straight conductor, the magnetic field will be in the form of concentric circles. Understood or not? So if the current is passing downward direction, so the magnetic field will be along this direction. So we can take. If the current is passing upward direction, the magnetic field will be anti-clockwise direction. It depends on how, in which direction the current is flowing, in which direction the current is passing. That depends. Understood or not? I hope it is very clear. So current carrying conductor. Okay, so around the current carrying conductor, magnetic field will be produced by using right hand thumb rule. By using right hand thumb rule, we can identify the magnetic field direction. I hope it is very clear, right? So now we can observe here. One more point, that is, near to the conductor, more crowdings will be there. Near to the conductor, more crowdings will be there. More magnetic field will be there. Understood or not? More crowdings represent more magnetic field. More crowdings represent more magnetic field. More magnetic field. Near to the conductor, field will be more. Away from the conductor, field will be less. Near to the conductor, magnetic field will be more. Away from the conductor, magnetic field will be less. So magnetic field is directly depends on current carrying conductor. So magnetic field is directly depends on strength of current. Strength of current is nothing but the amount of current passing through the conductor. So how much current is passing through the conductor? So it depends on it. Okay. So magnetic field is directly depends on strength of the current passing through the conductor. Understood or not? So that's enough. So this is about the point. And the next one is, so this is about current carrying conductor produce magnetic field, experience magnetic field and behaves as a magnet. Understood or not? Now you can see one more point that is so now you will take loop. This is a straight conductor. Now you will take loop. Loop. So now you can see so current is passing, magnetic field will be produced. So here you can observe, so the magnetic field will be, so you need to observe one thing. When the magnetic field is produced, so it will be like this. Okay. So at the center, the magnetic field lines will become straight lines. At the center, the magnetic field lines become straight lines. Okay. So here you can see. Okay, and here also. So this side is north. So there is one question based on it. If the current is passing, okay, so this side is north pole and this side is south pole. So we know when the current is passing through the conductor, magnetic field will be produced around it. If the current is passing through the conductor, magnetic field will be produced. By using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. So if the current is passing upward direction, the magnetic field will be like this. Okay, around it. So if you place like this also, the magnetic field direction like this we can take. So this side is north and this side is south. North and south. north and south. I hope it is very clear. Understood? Yes. So coming to the next one. So when the magnetic field is reaching, so at the center, these lines will become parallel lines. These lines will become parallel lines. At the center, so this magnetic field will add up to another magnetic field. So next one add up to another magnetic field. Next one add up to another magnetic field. So this magnetic field will be add up to one on each other. So one to each other. Then what happens? At the center, so uniform magnetic field will be created that is stronger than the magnetic field produced at the circumference. So the uniform magnetic field produced at the center is greater than the magnetic field produced at the circumference. I hope it is very clear, right? Yes, next one. So we can take one more, that is okay, so that is about loop. So now we will discuss about solenoid. Solenoid, you can see. So I am taking here 1, 2, 3, 4, 5, 9, 9. So here, if the current is passing through that, normally, so we are taking a straight wire, straight copper wire, okay, insulated copper wire, straight insulated copper wire is, so we took, okay. So then what we did, so we bent in the form of cylindrical shape. We bent in the form of cylindrical shape, and then we connected that solenoid to the circuit. Okay, so we took the long straight insulated copper wire. So what we did, so we wrapped that conductor. We wrapped in the sense folded. We wrapped, we folded in the form of cylindrical shape. That is connected to the circuit. If the current is passing through the conductor, then magnetic field will be produced. If the current is passing through the conductor, magnetic field will be produced around the solenoid. Yes? Yes. How the magnetic field will be there? So by using which law we can identify the poles, North Pole and South Pole. And one more thing, so we can also understand the point. Okay, so by using the standard method to identify the poles of the solenoid, by using compass, we can use compass, right? We can use compass to identify the poles of the solenoid. Yes or no? If the current is passing, automatically magnetic field will produce. So if you place north of the compass, if it is repel, then it is north pole. If we place south pole of the compass, then it is attract, then it is automatically north pole. Understood or not? So by that also we can able to understand. Now you can see if the current is passing. So I am taking here. So this is the 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So those I am connecting here. 1, 2, 3. 3 above I am connecting. 3 below you have to connect. 3, 1, and 2 and 3. So here I am connecting like this. Here I am connecting like this. Okay, so if the current is passing, so moving towards this side, then magnetic field also should reach to side. Then I am taking that is south pole. And here, so if the magnetic field is leaving, then current also leaving, magnetic field also leaving. Then you can observe that is north. This is north and this is south. So a current passing through the solenoid. It acts as a bar magnet. Same properties like bar magnet. So how the bar magnet behaves, here also same thing it will behave. Understood or not? So now you can observe here. So this side I am taking south, this side I am taking north. So at the center uniform magnetic field will be created. Uniform magnetic field will be produced. Uniform magnetic field will be produced. Understood or not? Inside. So uniform magnetic field will be there. Uniform magnetic field will be there. I hope it is very clear. Understood or not? Now, so comparison between bar magnet and solenoid. We have to compare the magnetic field produced. So we have to compare the magnetic field. So magnetic field produced by the bar magnet and magnetic field produced by the solenoid. So those points I have to compare. So point number 1, here magnetic field is fixed. In the bar magnet, magnetic field is fixed. Bar magnet, magnetic field is fixed. So in the solenoid, we can able to change the magnetic field. So we can increase the magnetic field by increasing the current, and the number of turns and the air gap between the turns also. So strength of current, if more current if you send, so more magnet will be produced, and the number of turns if you increase the number of turns also, magnetic field will be produced by the solenoid also more. So whereas coming to the bar magnet, magnetic field is fixed. We can't increase the magnetic field, we can't decrease the magnetic field. And here one more point, whenever we want, so magnet, if you connect the battery, automatically it acts as a magnet. But so this magnet cannot be removed, right, suddenly. So this one, what is that? Permanent magnet. Here, temporary magnet. Permanent magnet and temporary magnet. Understood or not? And one more point is, so if you suspend the magnet, always shows north and south direction. Solenoid shows always north and south direction. And one more point also, okay. So we can able to change the poles. So north pole and south pole. So I have mentioned here, right? So by changing the battery's direction, okay, so current is passing like this. If you change the battery direction, automatically, so poles also can change. But what about bar magnet? Poles we cannot change, okay? We cannot change the poles of the bar magnet. Understood? This is the permanent magnet and this one is the temporary magnet. Understood or not? So now we will discuss one more point, that is a current carrying conductor placed in the external magnetic field experience the force. Okay, so we'll discuss that point. So check once. Na na ni na ni na na ni na ni na 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 ni na ni na na ni na na na. A current carrying conductor placed in external magnetic field experience the force. So this is the stand. Okay. So. So I'm taking this the straight conductor. So I'm taking this as stand. And here is also stand. So okay, supporting stand. Dun, dun, dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. So I'm taking this the conductor aluminum rod. So that is AB. And here I'm taking a horseshoe magnet, U-shaped magnet. This is north and this one is south, north and south. Understood or not? So here you can observe. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. So here A. So okay, understand. So now you can see a current carrying conductor produce the magnetic field, experience the magnetic field. A current carrying conductor placed in the external magnetic field, experience the magnetic field. Understood or not? So a current carrying conductor placed in the external magnetic field experience the force. So by using what rule we can identify? By using Fleming's left hand rule. By using Fleming's left hand rule, we can identify in which direction the conductor will move. By using Fleming left hand rule. So you can observe. So this is the thumb indicates force acting on the conductor and index finger indicates the magnetic field and middle finger indicates the current direction. Okay. So along the direction of the magnetic field you have to place the index finger. So along the current direction, so you have to place the middle finger. So thumb shows the anyway force acting on the conductor. So if you place like this, so magnetic field will be upward and the current direction. So into the board, the force will act on the conductor. Coming to the short circuit, the direct contact of lever and neutral wire takes place, then heavy amount of current will be drawn from the mains. And overloading high voltage appliances on at a time, then also heavy current will be drawn from the mains. So it may lead to the short circuit. Live wire is 220 potential, neutral wire is 0 potential, earth wire is 0 potential. The live wire, the potential difference between live wire and neutral wire is 220. Okay, so 220 volts in India. And one more thing, so we can take the potential difference between neutral wire and earth wire is 0 potential. Okay, so these are the points. So I hope it is very clear. So if you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. Thank you so much for joining and attending and listening. So discuss few questions related to magnetic effects of electric current. Few questions. Okay. So done.